Engine failure. An engine failure happens when an aircraft engine stops producing the power expected during flight. It can come from mechanical problems, damage from foreign objects, fuel problems, or other system faults. Modern passenger aircraft are designed to remain controllable even when one engine stops working. Twin-engine aircraft can continue flying with a single engine, while pilots follow established procedures to manage the situation. Engine failures are important because engines are one of the main systems keeping an aircraft moving safely through the air. Hydraulic system failure. A hydraulic system failure occurs when an aircraft loses some or all of the hydraulic pressure used to operate important controls and equipment. Hydraulic systems can power components such as landing gear, brakes, and certain flight control surfaces. A failure may result from a leak, damaged component, or loss of pressure. Large aircraft often have multiple hydraulic systems, so one failure does not necessarily mean the entire system stops working. The main concern is maintaining control and access to the aircraft's essential functions. Electrical system failure. An electrical system failure happens when an aircraft loses part or all of its electrical power. Electricity is used for instruments, communication equipment, lighting, navigation systems, and many other functions. Problems can begin with generators, wiring, batteries, or distribution equipment. Aircraft are built with backup electrical sources so that important systems can continue operating. The seriousness depends on how much electrical capability is lost and which systems are affected. Fuel system failure. A fuel system failure involves a problem with the systems that store, move, or supply fuel to the engines. Fuel tanks, pumps, valves, pipes, and monitoring equipment all play a role. A problem in any of these areas can interfere with the normal supply of fuel. Fuel-related problems have appeared throughout aviation history, including situations involving contamination, leaks, or equipment faults. Because engines depend on a continuous fuel supply, these failures require careful management by the flight crew. Flight control failure. A flight control failure affects equipment used to control an aircraft's movement. These controls help pilots change the aircraft's direction, altitude, and attitude. Modern aircraft use a combination of mechanical, hydraulic, electrical, and computerized systems depending on the design. A failure may affect one control or a larger part of the control system. Aircraft therefore include backup systems and alternative control methods to reduce the consequences of a single failure. Landing gear failure. A landing gear failure occurs when the aircraft's landing gear does not extend, retract, or operate as expected. Landing gear contains wheels, structural components, doors, brakes, and other mechanisms. Problems can come from mechanical damage, hydraulic issues, electrical faults, or components becoming stuck. The aircraft may still be able to remain airborne while the crew deals with the problem. Landing gear failures are particularly important because the system must support the aircraft during landing and ground movement. Cabin pressurization failure. A cabin pressurization failure happens when an aircraft cannot maintain the intended air pressure inside the passenger and crew areas at high altitude. At cruising altitude, the outside air pressure is much lower than at ground level, so aircraft cabins are designed to maintain a more suitable pressure. A problem can result from leaks, equipment faults, or damage to the pressurization system. Aircraft have warning systems and emergency equipment to help crews respond when cabin pressure changes unexpectedly. Structural failure. Structural failure occurs when part of an aircraft's main structure becomes damaged or fails to perform as designed. The structure includes areas such as the wings, fuselage, tail, and supporting components. Aircraft structures are engineered to withstand repeated loads throughout their operating lives, but serious damage, extreme forces, corrosion, or manufacturing problems can create risks. Structural failures are especially significant because the aircraft structure holds together the major systems and provides the strength needed for flight.